Hello everyone. Today I'm going to show you how to make a custom component in SwiftUI, and I'll show you just the way I do it. There's lots of different ways, but there's a bunch of tricks I can show, and what we'll also do is try to avoid using a geometry reader, and we'll see more about that later. We want to make a small signal strength indicator view. So this is just like the one you have on your iPhone. In the top right, there's a signal strength indicator, and it displays the strength of your cell phone network reception. So we can start by just creating a horizontal stack with 4 rectangles. So we'll create a new view called signal strength, and this will be a view. And it'll have a body, which is some view, and then we'll have an edge stack with 4 rectangles. And I'll just copy paste it for now. And then instead of our hello world text, we can write signal strength. And let's run this and see what it looks like. So here we have 4 bars, and it's kind of ugly. It fills the entire window. The window has a fixed size, so we cannot change any of the size, and we need to improve upon that. So what we can do is add a frame to our signal strength. So let's say 100 wide and 50 high. And it feels maybe a little bit weird to have 2 frames in there. So our signal strength is now here. We can not resize the window, but the signal strength is the right size. Now, what happens when we write this double frame is that first SwiftUI proposes a size to the outermost frame. So this is during the layout phase. So the size is proposed, and the frame has a fixed width and height. So 1920 by 1080, at least in pixels. And that gets proposed to its child, which is the innermost frame. That renders itself at 100 by 50. And then the signal strength receives that 100 by 50 and lays itself out. So layout proceeds top down. Then it goes back up, and the signal strength says, okay, I actually was 100 by 50. The fixed frame, the innermost one, says, okay, I was 100 by 50. And the outermost frame lays out its child within its own bounds. So in this case, it's centered by default. You can control that with alignment. So we can say alignment at top, and that's top center. If we run this, we see it at the top and at the center. But by default, it's centered. So that's sort of how layout works. And that's what we need to take into account when creating our own custom components. And ideally, we want to be able to control the width of the signal strength indicator from the outside by setting a frame, for example, or an aspect ratio or something like that. But until then, we can hardcode some things, and we want to have these bars to have different sizes. So the first one should be 12.5 points high. The second one, 25. The third one should become 37.5, and then the final one should have a height of 50. So let's indent this and run it. And now our bars look almost correct. They're centered by default in the edge stack, so we can control this by setting a bottom alignment. And here we have our signal strength indicator. So if you want to have a fixed size, that's fine, but this is not really the way normal SwiftUI views work. And normally we would want this to respect the proposed size. So now it doesn't. So if we change the proposed size to 200 wide, it will be wider, but if we change the height, nothing will happen. So we can change this to 100, but it will still be only 50 high. And that's because we hard-coded these heights in here. So let's fix that. In UIKit, you might be used to doing something like layout subviews or something similar, maybe with constraints, but you express your height in terms of your parent. In SwiftUI, that's not so simple. Because the layout proceeds top down, the first thing that happens is the H tag is laid out, it lays out all its children, and then only then the H tag knows its size. So the children don't know about the size of the H tag directly. And a common solution it might be to use a geometry reader. This is something that almost everybody who's done any SwiftUI has heard of, and I think it's used a lot. So it works something like this. You say geometry reader proxy in, and then you move all of that code inside the geometry reader. And what this will do is when the geometry reader is rendered, it receives the proposed size, and that's inside the proxy, and you can access that using proxy.size. Now, we can use that size also. So we could try to print it, but that won't work because the geometry reader takes a view builder closure, and inside there we cannot print things. We could set a breakpoint, but there's another trick that I just wanted to show. If you want to print things inside a view builder, this is one way to do it. So you could write an extension on view and say printing and take any kind of A. So let's say an A, and then return self. So that's basically the current view. So that's what we're going to return, and then we print the value. And this way you could, for example, on the H tag say printing proxy.size. So let's run this. And now in our debugger, we see that we get proposed 200 by 100. If we would remove the inner frame, we should see a different size. So now we get 960 by 540 and so on. And we can now use this size to size our rectangles. And rather than having 4 rectangles, I think we should use a for each. So let's say we have bars equals 4, and then we do inside our H tag, we do a for each over the bars and set the correct height. So for each 0 until bars, we get an index in for the current bar, and we draw a rectangle, and we set a frame that has a height. And here we now need to say, well, we want to take the index plus 1, divide that by the total number of bars, and then we need a few self dots to make the geometry reader happy. And now if we run this, of course, we'll have very tiny bars, and that's because we're not multiplying by the frame height yet. So here we can say proxy size.height times the relative size. So here we go. Now we have a fully resizable signal strength indicator. I'll remove the print statement. And one thing I like to do when prototyping these kind of things is to add some sliders to really quickly test out things. So let's do that. We'll create a VStack here and then put our signal strength indicator inside and make sure that this frame is on the VStack. And then we can have some state variables. So we could, for example, have a size, which is a CG size, which is a size of 100 by 50 as the default. And then we can add an H tag with the text width and size.width and a slider that controls the size. So this takes a size.width as a binding, and then in the range of 0 to, let's say, 500. And we can do the same thing for the height. So here we can say height everywhere. And then finally we can use that size in our frame. So here we can say size.width, size.height. And then finally let's give, let's put these two H tags in a VStack and give it a fixed width so that they don't fill up the entire width. So here we can say frame width 500. So this should look a bit better. Okay, so now we can control the width and we can really see that we have a responsive control. So now let's try to get rid of our geometry reader, because there's a problem. Like for example, if we inside the geometry reader, we put a VStack with some text, let's say hello, and then add a closing brace, re-indent everything. Now if we run this, we'll see that it first looks like things are okay, although the hello text is very close to the slider. But if we put a frame around our signal strength indicator, so let's say border color blue, then we'll see that the view draws out of bounds. And that's typically not very good behavior. Sometimes you might want that, but we definitely don't want that. The problem is, of course, that our geometry reader receives the entire frame as its size, and it makes the bars as high as the entire frame's height. And we need to subtract the text. And rather than doing this manually, we can solve this by moving the position of the geometry reader. So it shouldn't be around the V stack, but it should be around the H stack. So like this. And now the geometry reader will only participate in measuring the H stack's height. So if we run this, everything is good again. So our geometry reader respects the size of the H stack. Now, there's other kinds of problems with a geometry reader, and that's sort of the price you pay for using it. So if you use a geometry reader, the size of that view will always be as large as the proposed size. And in our case, that's not necessarily a problem because we want to fill exactly the proposed size. But if you put a geometry reader around a text, for example, then the text will become the proposed size. And that's typically not what you want. And in general, I would say a geometry reader is a very heavy tool. And if you can avoid it, please do. At least that's my personal experience. It's almost always better to try to avoid that geometry reader. So what can we do? Well, we can take a look at rectangle. And rectangle is a shape. And it has no properties. It just draws a rectangle. And shape has this function path in rect. That's basically its only requirement. And it receives the entire rectangle in which to draw itself. And shapes by default, at least all the built-in shapes, they fill exactly that rectangle. And this is basically similar to what you would get from a geometry reader. So let's see if we can use that. So instead of rectangle, we're going to create a struct myView. And this is going to, or let's call it MyShape. It's going to be a shape. In order to be a shape, we have to implement path in rect. And then we can try to move all of this rectangle code in here. So let's move this over here. Now we want to move the part where we compute the relative height into a property. So we can say the shape has a relative height, which is a CG float. And then over here, we can create a MyShape with as the relative height, the code we just cut out. And the problem is that, well, let's change this to rect.size, is that we're using .frame. And .frame is a view wrapper. So it takes a view and puts basically a frame modifier around that view. And the return type will be a view. And we need to return a path ultimately. So we cannot use frame. But what we could do is take that rect that we receive as the input and modify it. So divide it up into exactly the height we need and then use that. So we can use our old friend cg_rect_divide. In Swift, it now looks like rect.divided. And then we take the relative height times the rect.size.height. And then we want to do that from the bottom. So that's the max y edge. And out of this method comes two rectangles, and we want to take the slice. So there's a slice and a remainder. We want to have the slice. And now we can draw our rect, so we can call path in the child rect. So let's put that into a variable. And now if we run it and add a return statement, I think things should be much better. Okay, so here we go. We still have our sizing rect, and we can actually now remove our entire geometry reader from here and re-indent this, and everything should still work. Excellent. So that's how you can do that, by really using the fact that we're dealing with shapes. And this MyShape, I think we could also call it relative height instead, and pull out this rectangle because it's not really specific. It could work for any shape. We just need to pass that shape in. So shape will be a property of type S, and S will be a shape. And this is very similar to how built-in modifiers work in SwiftUI. Now over here we can say relative height and pass in the shape, and we want to use a rectangle. And this should still work. But of course the API is a bit strange with passing in the shape like that and constructing this relative height. What you typically see in SwiftUI is something like an extension on shape and have a function relative height, and this takes in a height that's a CG float and returns you some shape. And here we simply create our relative height shape with self and then the height. And that's that allows us to instead write this as rectangle dot relative height, and that looks a lot more native to SwiftUI. So here we can now still control everything. Okay, so the next challenge is to make this a little bit more friendly and use rounded rectangles. So we can say rounded rectangle, and this one's a fixed size corner radius. So let's say 5 and see what that looks like. So this is maybe a little bit too much, at least when it's so tiny, but at this size 5 seems like a decent amount. But if we make things a little bit smaller, it's too round. So we really want that corner radius to be relative as well. So what if we could write something like a slightly rounded rectangle? This will be private to our file, so I think it's a fine name for that. Slightly rounded rectangle. And this is also going to be a shape. And here we're going to implement path and rect. And before we had a rounded rectangle with a corner radius. And now we can make this value dependent on the size. So one thing we could do, for example, say rect.size. Or let's say the minimum of rect.width and rect.height. And then we multiply that by maybe 0.001, so that's 1% or maybe 2% to get a tiny rounded corner. And maybe that's a little bit too little, maybe 5%. Yeah, that looks a bit better already. And of course you can control this and make a slider for this as well. So that's how you can do that. Now, let's look at a few more things. So I'm going to remove this text and add an aspect ratio over here. So we want to have an aspect ratio of, let's say, 16:9, and make sure that our signal strength indicator is always 16:9. So regardless of the size we propose, it always fits itself inside that proposed size with a 16:9 aspect ratio. We can even visualize this, so we can add a border, let's say call it a red, and then we can see how aspect ratio works. So the view gets proposed a large frame, and then the aspect ratio makes sure to find a box that fits inside that frame that's 16:9. And in this case, the view is taller than it should be. If we propose a height that's less, then you can see that it really expands, or it fits itself, compresses itself horizontally inside that space. So our new component works well like that. Now, there's one thing missing, and that's the horizontal spacing between the bars. This should be responsive as well. And to fix that, I think there are two solutions. So either we need to use a geometry reader and set the spacing on the H stack, because H stack is a view and it's not really a shape. Or we need to re-implement that functionality of H stack to put multiple shapes next to each other and re-implement it as a shape. I'd say try it out and see which one you like best. So my takeaway is that when you're designing custom views, always make sure that they work in the same way as other views so that they respect the proposed size, and try to avoid using geometry readers. See if there's another way, like for example here where we use a shape to lay out your views. Thank you.